In the last one, we identified a few basic trig equations, how to work with them, using our calculator, etc., etc., right? Now we're going to look at solving triangles, okay? Solving, okay, triangles. In other words, let me just draw a triangle here, and remember, if we've got theta over here, an angle, this is opposite, adjacent, hypotenuse. We are only working at the moment with right angle triangles, right? Now, let's say they give us something, right? Let's say they give us a triangle that looks like this. Right? This is given. Right? And we say that is 25 degrees, and they tell us that this is 10 centimeters. What is the first thing we do? Yep, stand at the angle and look out and find opposite, adjacent, hypotenuse. Okay. Now, okay, A, B, C. Can we find the length of AB and of AC and CB? What is the length of AC and BC? In other words, those two. You say, well, but hang on, this is where trig comes in. Let's look at this. Hang on. Well, first of all, how do we solve this? We say we go to the angle, okay, and look what's known. We know opposite, right? So you start off with sine of 25 degrees must be opposite over hypotenuse. But opposite is known, 10 over h. So therefore, the sine of 25 degrees must be equal to 10 over h. Solve for h. That's the hypotenuse, isn't it? What is sine of 25 degrees? Look it up. It's a number. It's 0.4226. 10 over h. What do I do next? Okay. I make a new page and I slide this one down a little bit. Okay. Right. What do I do next? I say, right, sine of 10. Now, how do I solve for h? Cross multiply. Okay. Not, the bulk of all these are cross multiply. Virtually every one of them is cross multiplication. So I say 0.426 times h must be, because that's over 1, 10 times 1. Therefore, now I must divide by 0.426, right? 4226, I think it was, all right? Yep, 4226. And we end up with h equal to 0.422 is going to be 10 over that, 23.66. 23.66, what? We were given centimeters. Please, in these, remember, I'm going to write it in red, the units. NB. Okay. If they don't give you units, then that centimeters would be units. Okay. Don't forget it, because you're actually working with lengths now. Right. Ditto, we then say, okay, now we know the hypotenuse, right? What do? I go back and I fill in 23.66. You always go back to your drawing and put in what you've worked out. You're going to see me do the same in physics. Those of you doing physics with me, you'll see in there, we always go back in our electric circuits, in our vectors, in everything we do, we put it back. Because that is the key to seeing what you've solved for. And it cuts your time down to work out what the next is, okay? Right, now I need to know adjacent. Well, okay. So what could I say? I could say, well, tan of 25 degrees is equal to 10 over A, right? So 0.4663 must be equal to 10 over A. Cross multiply, right? A times 0.4663 must be 10. Therefore, A is 10 over 0.4663. A is 21.45 centimeters. Go back, okay, and put in A is equal to 21.45 centimeters. Can you see that we've solved all of it? Okay. Now, hang on. You can check it. How? Well, what is 21.45 squared plus 10 squared? Okay. And then that is equal to h squared, isn't it? So what is hypotenuse then? Is the square root of that, right? And if you work it out, you get 23.66 centimeters. Tick, tick. Correct. Okay? These are actually, once you get into the hang of them, they're actually real fun because they go by so quickly, okay? And they give us problems to solve, okay? Let us say they give us an example like this. Let's just do this example, okay? They've given us a triangle that looks like that, all right, over there, okay? They've told us this is 90 degrees here, all right? And they've told us that this length over here is 10 centimeters, all right? And that's a horrible 10, so I'll redo it. Okay, 10 centimeters, okay? And they've said that's A, C, D. And then what they've done, okay, is from there, all right, they've taken another triangle off there and said that's 90 degrees. C and B is over here. Okay? And they have said to us, okay, one angle given is 50 degrees over here. All right? 50 degrees. And they have asked us for calculate the length of X and Y. Okay. Well, they're actually very easy to do. What do? We always start where we have most info. Duh. That's logical, isn't it? If you're trying to solve a problem, you go where you've got the most information and start at that point, don't we? That's how we do it. If the wheels are flat, you look which wheel's flat. And then you solve that wheel's problem, right? We do the same in maths, in physics, in chemistry, okay? In anything, really. What do? Is say, right, where have I got the most information? We have got the most information. I'm going to use green. Here, 50 degrees and a length given. So, stand at the angle, identify opposite, adjacent, hypotenuse. Okay? Now, the next step is to move from this triangle through to the triangle we're looking for. It's a case of moving through to the triangles we're looking for, right? Okay, so here I need to find H, right? So I'm looking for H. So what have I got? I've got opposite and I'm looking for hypotenuse. So link opposite and hypotenuse. That is sine of 50 degrees. Great. Great, of course. Okay, you could have gone, right, this one is 40 degrees. I haven't put it in yet, but there we go. So opposite sine of this angle is opposite over hypotenuse. So therefore, sine of 50 degrees, opposite is 10 over h. Cross multiply and you end up with h equal to 10 over sine of 50 degrees, which is going to be equal to 11.55. And then I go and I put that in, 11.55 centimeters. Now I'm in this triangle. Now I go into my new triangle and I say, right, I'm given that angle. Of course you could go and work with that one there, a 50, if you wanted to. All right, doesn't matter. But I've got this one, so I find opposite, adjacent, hypotenuse. Can you see the others now are gone? I've finished with that triangle. So what do? I work in this triangle. I've got adjacent as 11.55, and that's my angle. So opposite, I can say tan of 40 degrees is opposite over adjacent, which is opposite, don't know, adjacent 11.55. Therefore, opposite equals 11.55 times tan of 40 degrees. Okay? And the answer that I get, 11.55 times the tan of 40 degrees, is 9.69. So I go and I put that's 9.69 centimeters. Yes, I can now use Pythagoras to work out x, can't I? Okay? But let's use trig again. All right? Let's have a look and see, right, what am I going to do here now? Okay, in the triangle, I've got that. I've got, okay, opposite and hypotenuse. Okay? But hang on, I've got adjacent and hypotenuse. Let's rather work with the one we've got. So we say cos of 40 degrees is going to be adjacent over hypotenuse. Adjacent, I know. Adjacent was 11.55 over h is equal to cos of 40 degrees. And then I go and I say, right, therefore, h in this case, okay, remember it's now a different triangle, h is 11.55 divided by the cos of 40 degrees, which is going to be 15.01 centimeters, okay? And what do? I go and I put that onto my drawing, and I say that is going to be equal to 15.01, okay? All right. So what do I do next? 15.1, sorry, my bad, 15.1. I didn't round it off. It's 15.1, and just go back down here. 15.1 centimeters. And you can check with Pythagoras, okay? What is 11.55 squared plus 9.69 squared? And all that to the power of a half is the square root. You get 15.1 centimeters, right? Well, let's have a look at a different kind of problem. Before we do, there's two things that we talk about here. One is the angle of elevation, which is how far something is above me. The opposite is the angle of depression, is how far down below, right? So therefore, if this is my line of sight and I measure an angle up, this is angle of elevation, right? And if I measure an angle down, over here I call it angle of depression. Okay. Now, they give us a drawing like this, okay? Quite a fun one. Let's just put it all onto a new page, okay? Okay. Okay, there we go. Okay, now they give us two buildings, all right? Let's draw it first of all, right? Draw it with me, okay? Get a piece of paper and draw this. They've given us two tower blocks, and they've said this is block 1 and block 2. All right? Then they've told us, let's call that B and A and D and C. So they've told us that if I stand at B, all right, and I look up, my angle of elevation is 30 degrees there, right? And my angle of depression is 40 degrees down there, all right? They've told us that we've measured, we know the height of this is 36 meters, all right? Now let's see They're going to ask us how high is block 2, how far apart are the buildings, and they've said they want to join a 50 slide A to B to C. Okay? In essence, they've asked us for a whole lot of information. In the real life, you would basically take a colored pencil and say, what have they asked us to find? Well, they've asked us to find that length, they've asked us to find that, and they want to know how high that is, okay? Now, the first thing to realize in all of these is everything is at 90 degrees, okay? We don't deal with the Leaning Tower of Pisa here at all, no. We say it's at 45 degrees. So what do? I also say that the height of D must also be 36 meters, right? Because that is a horizontal measurement, right? So let's start. Where have we got the most information? The most information that we've got, okay, is in this triangle here, isn't it? Okay, let's have a look. We've got in the triangle here, okay, first of all, identify all the triangles that we've got. But the most information is in the triangle there, isn't it? Okay, we know that's 36 meters, and we know that that is 40 degrees, right? Over there, right? Which means we also know that that is 36 meters over there, right? That is between point D and C. It doesn't matter which way of these, because that is also 40 degrees, isn't it? Because that's parallel to the ground. Over short distances, we don't account for the curvature of the earth, okay? So now what do we say? We say, okay, therefore, let's work it out if that's 40 degrees. Oh, I can work out how far apart the buildings are, can't I? I can say that tangent of 40 is opposite over adjacent. I must go and say opposite, adjacent, hypotenuse, right? Therefore, I can say tangent of 40 degrees is equal to O over A, right? And that is then going to be equal to 36 over A, or the distance if you like, and therefore A is going to be equal to 36 over tan 40, which is equal to 42.9 meters. And then what do? I go back up and I put 42.9 meters in there, okay? Straight away, either through Pythagoras or through trig, you can go and you can find the hypotenuse, right? I did it here using trig because that's the cable length. I said, hang on. Oh, wait a bit. Because I need h now, and I've got opposite. Sine of 40 degrees is equal to opposite over hypotenuse, which is 36 over h. Therefore, h is equal to 36 over sine of 40 degrees, right? And if I look at that, 36, that is equal to 56 meters. So now I know that that is 56 meters, right? Now I go to my triangle above, right? You can see this is triangle ABD, right? I'm going to write triangle ABD down here. A, B, D, right? Like so. This was 30 degrees. Now let's put in, what do we know? Hang on a sec. We know that this is 42.9 meters. How? Well, go to your diagram. You actually put it in. 42.9. This is 56. Right? So we know that that's 42.9. Right? We know it's 42.9 meters. Okay, now we need to know that height and the hypotenuse. Can you see we're working everything out? So we go to our angle and we say, right, opposite, adjacent, hypotenuse, right? What do we do now? Well, the things we've always done, we say, okay, let's see. I've got adjacent, okay? Oh, hang on, I can say cos of 30 degrees is equal to adjacent over h, which is 42.9 over h. Therefore, h is going to be equal to 42.9 over cos of 30 degrees. All right, and if I go 42.9 divided by cos of 30, 42.9 divided by cos of 30, I get 49.5. So now I go back 49.5 meters. Okay, let's now work out O. Okay. How do I do that? I say, oh, hang on. Opposite over adjacent. So I can use tan of 30 degrees is opposite over adjacent. Fill in what we know. Opposite I don't, but adjacent is 42.9. Therefore, opposite is 42.9 times tan of 30 degrees. And I go 42.9 times tan. Let's have a look. 42.9 times tan of 30 is equal to 24.8. Okay, right, so I know that is 24.8. Essentially, we'd go back, we'd say 24.8, we'd have, that'll be 24.8 over there, and the hypotenuse length over here was going to be 49.5, all right, 49.5 meters. Therefore, how high is tower block 2? Tower block 2 is equal to height is 36 plus the 24.8 that we just worked out. That's about 60.8. Okay, it's about 20 stories. Right, EYS, okay. 20 stories, all right. I just divide by 3. Okay, 20 stories high. That one's going to be, a little bit different. 12. So now, what's the total length of the cable that we need? It's 49.5. Okay, let's just go back down. Now I can answer it here. Let's change color, blue. Cable length is 49.5 plus 56. Right? 49.5 plus, not times, plus 56 is going to be equal to 105.5 meters. Right? They might have said you have only got 100 meters of cable. Will it work? Or blah, 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 blah. How do we do these triangles? Well, essentially, you go to your drawing and you find where you've got the most information. That's where we start. Then we identify opposite, adjacent, and hypotenuse with our pencil, okay? Or a colored pencil, right? And work with that triangle using the info you've got. Either you've got opposite, hypotenuse, or you've got adjacent. One of those three. Can you see that any trig equation, let's just look here, all right? Any trig equation, all right? Let's say sine of theta, opposite over hypotenuse. Cos of theta is adjacent over hypotenuse. And tan of theta is opposite over adjacent. Let's just break this down. Can you see that each has either got that or that, that or that, or that or that? You've always got 2 out of 3. If you've got 2, you can work out the third because there are only 3. So you've got to pick the trig equation. Don't use cosec, cotan, sec. You never use those, all right? You use sine, cos, tan because your calculator does that, and that's the way we work. So use the sine, cos, and tan. Look what you're given. Sometimes you're going to pick cos. You could have picked sine. It doesn't matter, right? As long as you've got the ratio adjacent over hypotenuse as opposed to opposite over, right? The trick, make sure you do the cross cancelling. That's how they're going to work, right? They want you to cross cancel each and every time, okay? That's how you do those. And when you've worked something out, you can check it with Pythagoras each and every time. If you have time, if it's a very complicated one, you can do a quick spot check with Pythagoras, right? Which is actually very quick on your calculator. The other side of it is go to your drawing, and as you work them out, fill in what you've just worked out. It closes the gaps down. If you don't put it on your drawing, you're not going to see it there, and you're not going to realize that you need that for the next step. That's the secret of this, is to put it on your diagram, because what you've just worked out, you're going to need in the next step and the next and the next. Okay? Thanks for watching triangles. Oh, where's this used? Land surveyors use this, right? If they're working out heights of buildings, heights of mountains, this is what they use. In fact, the process that they use for a lot of their measurement is called triangulation. Why? Triangles. Land surveyors set out triangles. They measure long distances with lasers, okay? They've got very thingy equipment. Just as, what is this? I've got a protractor here, and I've got a ruler. This here is if I can work out the angle and I point at something. That is the basis of an old sextant, right? Do you remember that? Any of you have read stories about old ships? Navigation of ships with stars. They would take angles and readings of stars to be able to plot their position. All right? In fact, it's still done. All right? You can imagine if a ship loses its electronics, okay, well, today GPS, everyone's got a cell phone, they'll probably be able to find you. But generally speaking, this is what we use. Thanks for watching. Triangles really, the whole trig part up till now is actually simple. The next stage is trig equations. Equally easy. I'm going to show you a recipe just like I've done for all the others. Cheers. Have a good one. Bye. See you next time.